Hi everyone. One way to graph absolute value functions is by using transformations, and I'm going to do it here using the equation. The first most important point that we need to transform is the vertex. On the parent function, y equals absolute value of x, we know that the vertex is 0, 0. Since the input of the coordinate is 0 and the input of the absolute value part is 3x minus 8, I can set 3x minus 8 equal to 0 to find the x-coordinate of the vertex. By solving, I get that the vertex's x-coordinate is 8/3. Now, this makes my life a lot easier. I know that when x equals 8/3, everything inside here is going to be 0. So all I need to do is -2 times 0 plus 1, and then I'll get 1. Therefore, my vertex is the point 8/3, 1. If you're like, whoa, what happened? Actually take 8/3, substitute it into the function, and you'll see that the part in the absolute value is just going to be 0. I'm going to start by plotting this point in the axis of symmetry on the graph. So, we're going to start by drawing the axis of symmetry at x equals 8/3 and the vertex at 8/3, 1. And what we might actually notice is it's probably easier to graph this if instead of using the number 8/3, we use the mixed number form of it, which is 2 2/3. Now that I have found the vertex, I just need to find another point. I know that on the function y equals absolute value of x, it has the point 1, 1 because the absolute value of 1 is 1. Like I did for 0, 0, I can take the input part, the 3x minus 8, and set it equal to 1, and by solving it, I get that x equals 3. Therefore, for f of 3, it's going to be -2 times 1 plus 1, which will give us -1. Again, if you look at what we did when we set the 3x minus 8 equal to 1, what we did was just found a x value that when we put it into that part is going to make it be the absolute value of 1. In other words, we just did the horizontal transformation on that point. Therefore, the graph also contains the point 3, -1. All I need now is one more point, but all I have to do here is use the graph symmetry. Because 3, -1 is 1/3 of a unit to the right of my axis of symmetry, there's also going to be a point 1/3 of a unit to the left on the axis of symmetry, or at 7/3, or 2 1/3, -1. Now, just draw the graph. So I'm just going to connect these points here from the vertex. And there's my graph. Notice that it is in the shape of a V, like the absolute value parent function. Also notice that it should be reflected over the x-axis, has a vertical stretch of 2, and then also has the horizontal compression and translation. So that's how you use transformations. More specifically, use the equation for transformation to draw a graph of the absolute value function.